Okay, just some more antiderivative practice. Say you're taking the integral of the square root of x plus 1 over 2 square root of x with respect to x. The first thing I would do would be to rewrite these just like we do when we're taking derivatives. So this equals the integral of x to the 1/2 power plus 1/2 x to the negative 1/2 power with respect to x. So when I do the power rule, I'm going to add 1 first. So 1/2 plus 2/2 is 3/2. X to the 3/2. Divide by my new power. That's like multiplying by the reciprocal, so a 2/3. And do it again for this term. Remember, you integrate term by term, just like you take derivatives term by term. So I add 1 to this, so if I add 2/2 here, negative 1/2 plus 2/2 is 1/2, so x to the 1/2. And then I'm going to divide by my new exponent, so that's a 2 over 1, and I still have this 1/2 here, plus c. So if I were to simplify this, this would be 2x to the 3rd, but I'm taking the square root, over 3. My 2's cancel out, so I'm just going to say plus the square root of x plus c, and that antiderivative is finished. For the next one, let's say you have the integral of, we're going to have x cubed but have the 4th root, plus a secant squared x plus 1. Step 1 is to rewrite it. I only need to really rewrite this term. So that is x to the 3rd, but I'm taking the 4th root. So when I do the antiderivative, I'll add 1 to this, so I'll add 4/4, and that is x to the 7/4. Divide by my new exponent, so that's 4/7. Go to my next term. I know that the derivative of tangent is secant squared x, so the integral of secant squared x is tangent x. And then I have to do the antiderivative of 1. Remember that that 1 is like 1x to the 0. So if I add 1, I get x to the 1st, divide by my new exponent of 1, and I'm just left with plus x plus c. If I take the antiderivative, the derivative to check, 7/4 times 4/7 is 1, x to the 3/4. The derivative of tangent x is secant squared x, the derivative of x is 1, and the derivative of a constant is 0. So all I have left to do is rewrite this. So this is a 4, x to the 7th, but I'm taking the 4th root, over 7 plus tangent x plus c. It's a plus. One more example. The antiderivative of 1 over x to the 4th minus secant squared x, all with respect to x. So I would rewrite this term, and that's x to the negative 4. So when I do the antiderivative, I add 1, that makes it x to the negative 3, divide by my new exponent, so divide by negative 3, that's the same as multiplying by negative 1/3. And then I know the antiderivative of secant squared x is tangent x because the derivative of tangent x is secant squared x. So I'm going to say minus, from there, tangent x plus c. Check by taking the derivative. Negative 3 times the negative 1/3 is a positive 1, x to the negative 4th, minus secant squared x plus 0. So all I have left to do is rewrite this. This is a negative 1 over 3, the x is in my denominator because of the negative exponent, minus a tangent x plus my constant of integration. And that would be the answer.